Welcome back to Aurora Tech Channel. Today, we're going to test Prusa's new machine, the Core One. I received this machine about 2 months ago, and I've made quite a lot of prints and tried to use it as my primary printer before releasing this video. This machine is available in 2 versions. The kit version, which requires you to assemble everything yourself, costs $950, while the fully assembled version is priced at $1,200. This is a CoreXY fully enclosed printer. The print volume is slightly larger than the Mark IV's 250 by 210 by 220 millimeters. The Core One offers 250 by 220 by 270 millimeters. The table space required is about 20 by 17 inches or 50 by 43 centimeters, having an even smaller footprint than an unenclosed Mark IV. While the vertical space required is about 22 inches or 56 centimeters, the Core One features an all-steel exoskeleton frame for maximum rigidity. It doesn't have an actively heated chamber, but thanks to its compact enclosed design, the heated bed alone can raise the internal temperature to as high as 55 degrees Celsius, which is great for materials like ABS, ASA, PC, and nylon that require a stable, warm environment. When printing PLA, TPU, or PETG in a fully enclosed machine, you usually need to open the door and top cover. But with the Core One's dual exhaust fans and vented top design, you can print most materials without opening the enclosure. The motion system uses linear rails on the X-axis, linear rods on the Y-axis, and a 3-lead screw-supported Z-axis. The X and Y stepper motors are 0.9-degree motors to help prevent vertical fine artifacts. The extruder is the same nextruder with a planetary gear system and 10:1 gearbox ratio as the Prusa XL, Mark IV, and Mark IVS. The maximum nozzle temperature is 290 degrees Celsius. It came with the same high-flow CHT nozzle like the Mark IVS. If you have old nozzles like the E3D V6 used on the Mark III, you can also buy an adapter to use them on the Core One or Mark IV. The hardware specs state that the bed temperature can reach up to 120 degrees Celsius, but it seems the current firmware limits it to 115 degrees Celsius. The print surface is the same size as the Mark III and Mark IV, so you can use your existing sheets on the new Core One. For bed leveling, it uses a load cell sensor inside the print head, which probes the bed directly with the nozzle. Z offset is set automatically. It doesn't have an auxiliary cooling fan, but it features the same 360-degree cooling system as the Mark IVS. In terms of network connectivity, it supports NFC, so you can use your phone to send Wi-Fi settings to the machine, or you can manually enter the network information on the touchscreen. It also supports an Ethernet connection. If you have multiple printers, Prusa Connect lets you manage them easily through the web interface or mobile app. You can also print locally without the cloud or go completely offline using a USB drive. For multicolor printing, the Core One is also compatible to the MMU3 that allows you to print with up to 5 colors, but it seems the kit for Core One is not released yet for now. Prusa has also introduced some optional upgrades for this printer, including a camera, a filtration system, a GPIO extension board for external device control, and an accelerometer for fine-tuning your input shaper if you decide to modify your printer. I would like to thank Prusa for sending us this machine to review, and I would also like to thank VOXELPLA for sponsoring today's video. VOXELPLA is a brand created by a print farm in Southern California, where they exclusively use their own filament across more than 150 3D printers running 24/7. This extensive real-world testing ensures consistently high quality and reliability. VOXELPLA Pro is a modified PLA that delivers higher impact strength and supports high-speed printing up to 500 millimeters per second with a flow rate of up to 25 millimeters cubed per second at a standard printing temperature of 210 degrees Celsius. Their new PETG Plus also handles high-speed printing just as well. Both filaments are affordably priced at just $16.99 per 1 kilogram roll. Orders of 4 rolls qualify for free shipping, and bulk discounts are available starting at 6 rolls. Filament profiles are included in Prusa Slicer and require no tweaking or tuning to achieve good results. In addition to filaments, they also offers accessories for Prusa and Bamboo Lab machines. For more information, please visit voxelpla.com. The printer arrived in a large box, much bigger than the Mark IVS, and it was heavier than I expected. The accessories were placed on top, while the machine itself was wrapped in cardboard with handles, making it easy to lift straight out of the box. Along with the machine, the package includes a double-sided smooth PEI sheet, a color touchscreen, various tools, a power cord, a USB drive, a user manual, and my favorite, gummy bears. Since this machine comes fully assembled, all we need to do is place the print surface and mount the screen at the front. The user manual recommends inserting the USB drive when turning on the machine for the first time so that the latest firmware update is applied before use. After a short wait, the language selection screen appears. Next, we select the printer type. Since this is a stock setup, everything can be left as default. Then, I connect the printer to my home Wi-Fi using the Prusa app and link it to Prusa Connect. Of course, if you prefer not to install the app, you can set it up directly from the printer's screen. In the Prusa app, select Add Printer, the printer is not connected yet, the model is Core One. Then choose the SSID and enter the password. Now, we use NFC to transfer this information to the printer. Just tap it on the NFC logo at the back of the machine, and it's done. Since I already have multiple Prusa printers, I will also add it to Prusa Connect. Once completed, the printer should now be visible in both the mobile app and the Prusa Connect web interface. Once connected, we run the self-test and calibration. The process starts with fan testing, followed by the motion system, including all 3 axes. Then the heaters. For the gearbox, no additional calibration is needed since this printer comes pre-assembled. In fact, all tests and calibrations can be manually selected later from the screen menu if needed. Now, let's load some filament and start the first print. The nozzle purges old filament, indicating that the machine was factory tested before shipping. Since there is no preloaded fast benchy G code, I start with a standard benchy. The printer begins by cleaning the nozzle at the front right of the bed, followed by auto bed leveling, which only scans the printing area. This benchy was sliced using the default 0.2mm profile in Prusa Slicer. While it's not as fast as some preloaded speed benchy G codes, the printing speed is still quite fast. For a sound test, with the door open, noise levels stay in the low to mid 50 decibel range, occasionally jumping to the high 50s. With the door closed, it stays in the mid to high 40s, occasionally peaking in the low 50s. Including prep time, the total printing time for the benchy is 42 minutes, which matches the slicer's estimate. The print quality looks great, especially with Galaxy PLA, which helps hide layer lines and minor imperfections. The cooling at the front looks good. The top surface is smooth, and there are no visible defects. Next, I run the same G-code again, this time with VOXELPLA Pro. The print quality remains identical, but since dark blue PLA has a slightly shinier finish, the layer lines are more noticeable. Cooling performance is consistent across both prints, and the top surfaces are smooth with minimal stringing. I will then start my benchmark test prints, beginning with the number slider to test clearance. The print finishes in 2 hours and 30 minutes, which is on the faster side of the average printing time of 2 hours and 30 minutes to 3 hours among the latest machines. The top surface printed beautifully with zero stringing. The bottom adhered well to the bed, and I can see gaps between the tiles. All tiles move freely. Next, I will print my own geometry model to test tolerance and see if the parts fit together. The print finishes in 1 hour and 29 minutes, which is in line with other fast printing machines. On the square side, it clears up to 0.05 millimeters and gets stuck at zero clearance, which is a perfect score. On the cylinder side, it also achieves perfect clearance. It seems both pressure advance and flow calibration are very accurate on the Core One. Then, I will print a honeycomb box to test the extruder's retraction. The first layer with tiny patterns looks good. This model requires the extruder to deposit a small amount of filament, retract immediately, and move to the next point. The print finishes in 1 hour and 57 minutes, slightly faster than average. All the honeycomb patterns were successfully printed without breaking. The bottom is mostly clean, with a few minor imperfections on the lid. Comparing this model across different machines, the Core One delivers one of the best results. Up next, I will test surface quality by printing the Robo Alpaka. The middle section of the model has more room for acceleration, and the print head moves quite fast. The print finishes in 4 hours and 42 minutes, which is an average time. The surface quality looks decent. Comparing it with other machines, starting with the Mark IV running input shaper firmware, the Core One is about 40 minutes faster. Despite the speed advantage, the surface quality of the Core One is also slightly better. When compared with the Bambu Lab X1C, the X1C is 34 minutes faster, and its surface quality is slightly better and cleaner. Compared to the Creality K2 Plus, the K2 Plus is 1 hour and 27 minutes faster, and I think it also has a slightly cleaner surface. Compared to the fastest machine, the FL Sun S1 Pro, the S1 Pro is nearly twice as fast, but the Core One produces much better surface quality. When compared to the printer with the best surface quality, the Chitu Plus 4, the printing time is almost identical, but the Plus 4 has better surface quality than any machines I have tested so far. Before testing other materials, I will print a single layer PLA sheet to evaluate the Auto Z offset. The first layer prints at 45 millimeters per second, which is not super fast compared to some machines that reach 100 millimeters per second. The first layer was printed perfectly and peels off cleanly without line separation. The print took 48 minutes. The top surface is flawless, with no areas squeezed too low or too high, and the bottom has a perfect mirror-like finish. Next, I will test some different materials, starting with PETG. I switched to a textured print surface from my Mark IV. It seems the first layer is slightly squeezed too low when printing PETG, but I will not manually adjust it and see how it turns out. This trash can is printing with 3 walls for extra rigidity. It took 6 hours and 19 minutes to complete. When printing a tall model on a bed slinger, the top layers are usually less stable than the bottom ones, but on the Core One, the layers remain consistent from top to bottom. The bottom was squeezed a bit too low, but it did not significantly impact the print. The inside of the trash can looks decent with minimal stringing. Then, I will print a phone case with FiberLogi FiberFlex. This TPU is Shore 40D or 85A, which is softer and more flexible compared to the more common Shore 95A. Due to its flexibility, the flow rate was set to just 2.5 millimeters cubed per second, so the print was super slow. It finished in 2 hours and 4 minutes. The overhangs printed fine even without support. I then used PETG to print the camera protection ring. I'm not a big fan of 3D printed phone cases, but this one looks okay. Next, I will print a camera grip using ABS. Before the print starts, the bed heats up to 115 degrees Celsius to increase the internal temperature. If you do not want to wait, you can skip this step. I pressed the skip button after the temperature reached 40 degrees Celsius, which took about 15 minutes. I applied glue and switched to another old print surface from one of my Mark IV machines. The first layer of the ABS print looks fine and is not squeezed too low like the PETG print. After 70 minutes of printing, the internal temperature reaches 51 degrees Celsius. The print finishes in exactly 2 hours. The result is a solid ABS print, not as flawless as PLA, as the transition from the base to the grip has some minor imperfections, but it still functions as expected. I added a metal tripod screw at the bottom to attach the grip, and it fits perfectly on my Leica M3. Then, I will print an even more challenging model, 2 ASA stackable boxes at the same time. The first layer of the ASA print looks great, with no noticeable oversqueezing like with PETG. As the print nears completion, there is some minor warping at the corners. The print finishes in 5 hours and 21 minutes. Despite slight warping, the boxes turned out well. The minor warping did not affect their functionality, as they still stack properly. The surface is also very clean, with no layer separation or cracking. Now, let's test some engineering-grade materials, starting with polycarbonate carbon fiber. I printed all parts of my propeller design on the same build plate. The first layer also printed perfectly without overly squeezed. The print finishes in 4 hours and 14 minutes, and every part turned out flawlessly despite being printed together. Even the small gears have clean, sharp teeth and work smoothly when assembled into the gearbox. The final assembly functions as expected. Next, I will use nylon carbon fiber to print a lens hood for my old Canon camera with a 50mm lens. It took 1 hour, 9 minutes to finish. The surface looks great, and although the Z-seam inside is not perfect, I trimmed it with a flush cutter, and the result is still very good. The lens hood fits perfectly on the lens, and the PETG filament complements the look of this vintage camera. After nearly 2 months of testing this printer, I have made many other prints. I will not go through them all individually, but here are some additional clips before we jump into the pros and cons section. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. After years of waiting, Prusa has finally delivered a standard-size CoreXY machine. Of course, the Prusa XL is also a CoreXY, but its large build volume and multiple tool heads come at a high cost, making it less accessible for everyone. This new Core One platform uses linear rails on the X-axis, linear rods on the Y-axis, and 3 lead screws on the Z-axis. With all parts being modular, it's a future-proof design that allows you to keep upgrading for years to come. 2. Print speed has improved. It's now even faster than the MK4S. While it may not be the fastest overall, it's on par with the average clipper-based CoreXY printers. It strikes a solid balance between speed, decent quality, high accuracy, and, most importantly, reliability. Just like other Prusa machines I trust to run overnight without worrying about a thing. 3. The CHT high-flow nozzle comes standard and can achieve a true flow rate of 30 millimeters cubed per second. The robust cooling system complements the high flow rate perfectly. Everything just works in harmony. 4. It's quiet, one of the quietest machines I've tested so far. Even when printing at high speed, it stays around 50 decibels when fully enclosed. You can keep the enclosure closed even when printing PLA and TPU thanks to the 2 exhaust fans at the back. With the top cover vents open, the fans automatically turn on once the internal temperature rises above 20 degrees Celsius for PLA and 30 degrees Celsius for PETG, or you can set it manually in the slicer. Besides that, as the enclosure is compact, even without an actively heated chamber, my room temperature is about 18 degrees Celsius, and the internal temperature can reach over 50 degrees Celsius with a 110 degrees Celsius heater bed when printing ABS. 5. Prusa Connect is a free feature-rich cloud service that lets you manage multiple printers and assign print jobs with just a few clicks. In addition to the web interface, the mobile app works seamlessly, allowing you to browse models from printables.com and send them directly to your machine for great results. 6. It features updated capabilities such as NFC for Wi-Fi setup and cloud configuration, making the experience more modern and user-friendly. With the optional GPIO board, you can even use G-code to send digital signals to external devices, and with everything on this printer being open source, it truly unlocks endless possibilities for advanced users. You could technically build a small-scale Prusa AFS to automate your print farm. 7. Prusa has a solid track record of long-term support. For example, even an 8-year-old model like the Mark III, which was released back in 2017, still have firmware updates released just 4 months ago. The print surfaces on your older printers, as well as those nozzles on the Mark IV, they can be used directly on the Core One. As for older E3DV6 nozzles from the Mark III, you can still use them with an adapter. If you own the Mark IVS, you also have the option to upgrade to the Core One. However, replacing that many parts to convert a bed slinger into a CoreXY machine may not be the most cost-effective approach. In most cases, selling the old one and purchasing a new Core One might make more sense. As another good thing of Prusa is, unlike many older 3D printers that lose their value quickly, ever-used Prusa machines tend to hold pretty good value on eBay. Now for the cons. 1. The Core One still uses Prusa's own version of Marlin-based firmware, while it has added input shaping since the Mark IV, and is now capable of printing even faster with decent quality, the surface finish still isn't the best, mainly due to the limitations of Marlin's input shaping implementation. It's still better than most clipper-based bed slingers and low-end CoreXY machines, but not quite as good as some of the latest, more refined clipper-based CoreXY printers. 2. The optional Buddy 3D camera is a nice addition, but it's essentially a standalone unit that draws power from the motherboard via the USB-C connector. It connects directly to the cloud-based Prusa Connect platform, so if you prefer to run everything locally within your own network, the camera becomes unusable. It works by uploading a snapshot every 10 seconds or so to Prusa Connect, giving you a recent image of what's happening with the printer. However, it doesn't support real-time video monitoring, not even at a low frame rate. Although the camera includes a microSD card slot, it can't be used for time-lapse video recording either. While having a camera is better than nothing, this is far from an ideal solution. 3. One minor issue I've noticed since the release of the Mark IV is the nozzle cleaning process. It can sometimes leave marks on the print bed, especially if you start a print immediately after changing filament. Using just the lower corners of the print surface for nozzle wiping isn't as effective as the silicone cleaning pads found on other machines. I saw the nozzle cleaning failed message a few times, which I rarely saw on my other Mark IV or 4S, even though they're essentially running the same firmware. When I asked Prusa about it, they suggested it might be caused by the bed being slightly out of level. Whenever I saw the message, I simply used the screen menu to run a Z-axis test, which moves the bed to the bottom and realigns it. It would be a nice improvement if the printer automatically performed a quick 3-point check and lowered the bed to realign the Z-axis before every print starts. 5. The price of Prusa machines has never been particularly competitive compared to other budget printers on the market. I saw they recently partnered with PrintedSolid.com to ship some products and manufacture their filaments in the US, which I expected would help lower the overall cost for US customers. However, when I visited their website and checked the pricing, both the Core One and MK4S were listed at a higher price than on Prusa.com. While ordering from Printed Solid means you won't have to pay international shipping or worry about exceeding the $800 import threshold that could trigger import tax. Once you break down the total cost, it ends up being about the same. I think most US-based buyers were expecting to pay at least the same price as seen on Prusa.com, if not lower, along with free shipping and no import duties. 6. Although Prusa's production capacity is improving, it still doesn't seem to be keeping up with demand. As of today, I saw that the first batch of the Core One kit version is expected to start shipping in March, but if I place an order now, there's no clear indication of which batch I'd fall into. I'm not sure if there's a separate page to check the status, but I believe every customer would appreciate knowing exactly when they can expect to receive their machine before clicking the order button. In conclusion, the Core One is a solidly built machine and has a future-proof CoreXY platform. Its performance is top-notch, and the software, including the Screen UI, Prusa Slicer, and the Prusa Connect Cloud service, is among the best available. As I've mentioned before in my videos, my most used printer has been the fully enclosed MK4, which you've probably seen running in the background while I test other machines. However, the Core One will likely take its place as my go-to printer among the dozens of machines I have. Of course, there are still some limitations with their Marlin-based firmware and the 32-bit motherboard, but I can live with them. What I'm looking forward to is seeing the MMU multi-filament system for the Core One. I'd love to see Prusa not only release an MMU upgrade kit like the one for the MK4S, but also integrate the MMU3 into a single compact unit. The only real drawback of the current MMU3 is the amount of table space that it requires. If they can address that without relying on users to create DIY solutions, it could offer a significant advantage over all the current cut and poop multicolor systems on the market. Since the MMU system completely retracts the filament during color changes without cutting or flushing, it wastes almost no material aside from a small prime tower. In some cases, you can even eliminate that waste entirely by using the residue as infill. Personally, I really enjoy the overall Prusa printing experience. If you're tired of buying a new printer every year and watching your old ones collect dust, and would rather have a reliable machine you can continue using and upgrading for years to come, the Prusa Core One is definitely something to consider. I'm giving it the title of Most Reliable Future-Proof CoreXY Printer on my recommendation list at auroratechchannel.com. My website also tracks and monitors the prices of popular machines to help you find the best deals. All the links can be found in the video description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.